make the tutorial so you can use it to prep for the exam number 6 on Friday, which is tomorrow. So let's get it started. Problem number 1. So this is quiz 6, question number 1, AP Physics. Okay, problem 1, you have two boxes sitting on a frictionless surface. The box number 1 is 12 kilogram. Box number 2 is 10 kilogram. Someone pulling box number 2, 60 Newton applying 160 degree applying 100 Newton, and someone pull this one at at 60 degree northwest applying only 10 Newton. So we see that box is going to accelerate this direction. We want to find the acceleration of the system. So again, this is mass 2, so you're going to call this is Fg is equal to m2g, and that is 100 Newton. This is 160 cosine theta. So 100 cosine 60, and that would be 50 Newton. And this is 100 sine 60, and that would be 87 Newton. This is normal force. 100 minus 87, 13 Newton. This is Ft. We are done with M2. Now we're going to do M1. This is Fg is M1g. This value doesn't matter. Value at the y direction doesn't matter because there is no friction. So 120 Newton. This is Ft. This is Fy. How much? 10 cosine 60, 8.7. I'm gonna say 9. So 111. Fn is 111 Newton. Fx1, this is Fx2. So we're gonna call it Fx2. Okay, Fx1 is how much? 10 cosine 60, which is 5 Newton. Newton's second law tells us Fx2 minus Ft is equal to m2a. So Fx2 minus m2a is equal to Ft. Here you have Ft minus Fx1 is equal to m1a. So Ft is equal to m1a plus Fx1. Okay, so you're going to say Ft is equal to Ft. Hopefully you see my handwriting over there. So I'm going to move it this way. m1a plus Fx1 is equal to Fx2 minus m2a. So m1a plus m2a is equal to Fx2 minus Fx1. So a m1 plus m2 is equal to Fx2 is 50. Fx1 is 5. So acceleration is 45 m1 plus m2. So acceleration is 45 divided by 12 plus 10. So acceleration is 2.04. I ask you for 2 sig fig, so acceleration is 2.0 meter per second square. If you make any mistake, there is no partial credit, you just don't make mistake. This is step problem 2. Problem 2 has friction. Problem 2, quiz 6. Problem 2 has friction. Again, 12 kilogram, 10 kilogram. You pull it by 110 Newton at 60 degree. They are sitting on a surface with 0.1 kinetic friction. This is M1, this is M2. It's to find the acceleration in the system, 3 sig fig. So M2, this is 100 Newton. Fx, 100 cosine 60. Fy, 95 Newton. 100 sine 60. So Fn, 100 minus 95, 5 Newton. Ft, Ff, 0.1 times 5, 0.5 Newton. You have 55 minus 0.5 minus Ft is equal to M1A, M2A. Okay, now let's M1, 120 Newton. Ft, Fn is 120 Newton. Ff is 120 times 0.1, 12 Newton. Ft minus 12 is equal to M1A. So Ft is equal to M1A plus 12. 55 minus 0.5 is 54.5 minus M2A is equal to Ft. So we're going to say Ft1 is equal to Ft2. So Ft1 is M1A plus 12. Ft2, 54.5 minus M2A. All the acceleration has to be at the same side. Minus 12.0. A is equal to 5 minus 0 is 5. 4 minus 2 is 2. So 42.5 divided by 10 plus 12. Acceleration is 22 goes to 42 once, 1.93 I believe meter per second square. 2 sig fig. You don't get any partial credit for making mistake. Just don't make mistake. Problem number 3. Problem 3, I'm already tired. All right, so problem 3. Problem 3, the story is I did not give you the mass. Okay, so let's start from here. This is M1. I never gave you the M1. This is M2. This is 10 kilogram. This is you pull it by 60 degree applying 110 Newton. mu k is 0.1. That's it. I ask you to find m1. Again, as usual, m2, which is given. Oh, by the way, I also give you the acceleration, which is 2 meter per second square. Okay, so this is m2g, and that should be 100. This is fx2, 110 cosine 60 should be 55. Fy, 110 sine 60, 95. 100 minus 95, Fn must be 5. 5 times 0.1, that is our FF, 0.5. And this is our FT. So now we're going to write Fx2, 55, minus 0.5, minus Ft is equal to M2A. Okay, so that's good. We can update it more. 55 minus 5 is 44.5 minus Ft is equal to M2 is 10. 10 times 2, 20. So we're going to bring 20 over there. So 34.5 Ft. So Ft is 34.5. Now box 1, don't have it. So this is our Ft. This is our M1g, which we don't know what it is. This is our Fn, which is M1g. This is our FF, which is mu k, which is 0.1 M1g. You're gonna write Ft minus 0.1 M1g, which is 10 actually, equal to M1a. So Ft1 or Ft is equal to 10 times 0.1 is 1, so M1 is equal to M1. We don't know, but we know the acceleration. So I'm going to send everything to the other side. Ft is equal to 2m. This is M1 2, so 2m1, 2m1 plus m1. Oh, okay, I see 3m1. So Ft is equal to Ft. Ft1 is equal to Ft2. Ft1 is 2m1 plus m1. Oh, so I better say 3m1. Ft2 is 34.5. So m1 is equal to 34.5 divided by 3. So m1 is 11.5 kilogram. It's not 12. If you write 12, you get 0. There is no partial credit. Just don't make mistake, because you just don't. Over problem number 4. So here is problem number 4. So I give you two scenarios, scenario 1, scenario 2. I'll do the scenario 1 and 2 here. So no friction, and friction is 0.1. There is a mass 2, there is a mass 1. 30-degree incline, 30-degree incline. Okay, so I ask you, whose mass moves faster and what percent? Okay, so let's do m1 there is no friction, so only this force Fg parallel. So we're going to say Fg parallel is equal to ma, mg sine theta is equal to ma. So A is equal to G sine theta. So A is equal to 10 sine 30. So A is equal to 5. Here we're going to say there is a friction. So this is FG parallel. This is FF. So you're going to say F net is equal to, we're just going to say FG parallel minus FF is equal to F net. Mg sine 30 minus mu k mg cosine 30 is equal to F net. Okay, so you notice that F net is ma. You notice that m cancel. So A is G sine 30 minus mu k G cosine 30. So G is 5, G is 10 sine 30 minus mu k is 0.1, 10, cosine 30 is 0.86. So A is 5 minus 0.86. So A is 4 minus 14. Okay, so now V square is, V1 square is 2 A1 D1. And V2 square is 2 A2 D2. So you're going to say B1 squared, V2 squared is equal to 2A1 D1 to A2 D2. 2 to cancel, D cancel. And then say we're going to say V1 squared, V2 squared is equal to A1 over A2. So you're going to square root both sides. So V1 over V2 is equal to A1 is 5. A1 is 5. A2 is 4.14. So V1 is equal to 2.2 and A1 is equal to 2. So now finally we're going to do percent ratio. We're going to say V1 minus V2 over V2 is times 100. So V1 is 2.2 minus 2 divided by 2, and that is 10%. Okay, all right. Mass is 70 kilogram. The guy started jumping from location A, crouching from location A, and taking up location B at his max height at location C. So we're going to say this is negative 0.4 meter, this is 0 meter, this is 1.1 meter. This velocity is known. This velocity is known. This velocity is not known. This acceleration is not known. Okay, so let's working on them. So you're going to say V F squared is equal to VI squared plus 280. We have to take advantage. He's crouching over here. This is his max height, so velocity has to be 0 over there. So we're going to say this is VC squared because we know the velocity over there. VB squared, we want to know the velocity at there. 2A, since he is here to here, then we have to use this height, 1.1. Okay, and this is G because he is in the free fall from B to C. This is 0. VB square we are trying to find. This is 2, 10, rather negative 10, 1.1. So velocity is, velocity at location B is 4.7. VA square is 0. Velocity is over here 0, 2. A we are trying to find. Now we are using crouching, 0.4. Okay. So acceleration is 27.5. Okay, now at location B, just before he take off, this is what's going on. His weight is mg